Hello, everybody. Hello, everybody. Hello. I know it's after lunch. You are currently, digesting. But I hope that after this talk, you will have more things to digest, which is not the lunch that you had. Before I'm going to start, I want to present the 20 millisecond problem. What is this 20 millisecond problem? I'm doing web development for 2 decades. And in my life, most of the things that I'm currently doing in the last decade is more like performance tuning and doing a lot of stuff regarding how to make your application faster, either using some APIs or removing some barriers that you will need in order to, ship some request to the server. And whenever you need to do a request to the server, you are going to present the 20 millisecond problem because you have 20 millisecond latency for each request. And it becomes much higher payment whenever you're doing a lot of requests or whenever the server is crowded with a lot of requests that other users are doing as well, making sure that the performance of your application will decrease in your user's browser. And all of this because you don't have the power to do things like, algorithms, summarizing of articles, proofreading, and anything else that the AI is doing. And AI is giving us the power, but we need to go to the server and fetch or get the response to our prompts. That's what we are doing today. So the idea of this talk is, why not take the brain of the AI, put it inside your browser, and then instead of going and paying those 20 milliseconds latency or more, just prompt an in-memory or in-device AI. Is that a thing that can happen? Sure. And this is the idea of this talk, and this is what I'm going to show you in the next 40 minutes. But before I'm going to do that, hello, my name is Gil Fink. I'm the CEO of Sparksys. This is my own boutique consulting company. We have only one employee. And I'm currently a web development and web technologies GDE, Google Developer Expert, in the last 8 years. I've been a Microsoft MVP for 13 years, up until they said that I'm not doing any Azure and Microsoft Technologies community things, and they said bye. I wrote a book back in 2014 called Pro Single Page Application Development, and the idea of the book was to present the principles of how to create simple page applications, but I did a mistake in that book. I wrote it with a framework, not a framework, a library called Backbone.js. Who used Backbone.js? Okay, not a lot of you. This is the father of all the component frameworks that we use today, React, Angular, Vue, whatever. And the principles from that book are still relevant for today, but the book is old. So whenever I see it in places that I arrive, it's like a stand for a screen, the book itself. So what we are going to do in this talk, I'm going to, first of all, talk about browser in-device capabilities. Is it something that we want? Is it something that we have to have? And then we will get familiar with some APIs that you currently can use in Chrome at the moment, but are currently standardized to all the browsers. So this thing is going to be something that you will probably be able to use in the future, okay? Now you will have the opportunity to think about scenarios how to use it. And then we will prompt a little bit in order to, we're talking about AI. We need to prompt. So in today's development, whenever you are using or leveraging AI, what you are currently doing is, of course, going to the server, to the cloud API, prompting the cloud API, whether it's ChatGPT, Gemini, Claude, or whatever. Or if you want, you can install an LLM inside your network, but it will force you to have a lot of storage for that model, because those models are enormous, big, and you will need a lot of computation power in order to run them. Okay, so you have very big server farms in order to run those models, in order to get the responses that you need. And whenever you're doing that, whenever a user like us is working with the AI, what they're doing is like they're writing inside the prompt, okay? And then all the request is being sent to a remote server or in the in-premise device. And a lot of calculation are being done during that process, and you get a response. Sometimes the response is very, very slow. Sometimes the response is very, very fast. And the response is, of course, streamed to you by the AI, of course. Now, what if there is no internet connection? Never happened to you. Real. Okay, so what's going to happen to an application that is doing an AI call to the cloud server? Is it going to work? Or we will have to wait in the plane for things to happen, because the application that you were using stopped working because we are offline, flying in the plane back home. What about privacy? Can we send to the remote AI private things? Do you want to share your ID, the telephone numbers of all your friends, and anything else which is private to you with the AI model? And then that AI model can use all the details that you provided. What about if you want a very fast response? Not want to wait to the responses of the AI, which is in the remote cloud. So answering all of these questions, you can today use in-device AI APIs. Currently, as I said, available in Chrome, but will be still being standardized to be available in all the other browsers. All the other browsers vendors are going to give it that to you. Whenever you have a browser in-device API, you have privacy, because you're working in a local model, you're working with the local model instead of going to the cloud. The speed of the answers is faster. You don't have to pay the latency of the web. You don't have to pay anything. Paying is also something that you don't have to do. You don't have to pay for the tokens that you're using because it's local in your machine. And if you're offline, your model is still available to you and you can still use it. And this adds a lot of power to our hands as developers. Now, if you ask yourself how it works, then there are a lot of new APIs currently, as I said, in Chrome, task APIs. These APIs are using expert models and fine-tuned models, small models, in order to give you availability for simple tasks. You will see it in a moment. And through Gemini Nano, which is the AI model that you can install in the browser, you can use the exploratory API of Prompt API, which we will use later on in this talk. And what the model is doing is it uses the CPU and GPU of your machine in order to do all the AI runtime and processing, which is nice. You don't have to go to a big data server and waste a lot of power, energy, and etc. So what built-in task API you currently have? So currently you can have or use a lot of new APIs like Translator API. If you want to translate something to another language, available to you. Language detector, you can identify which language the user is using through a model. Summarizer, writer, and rewriter, and proofreader. In order to do that, in order to explore these opportunities, you will have to do a prerequisite, which is all those APIs are available under feature flag in Chrome. So you will have to enable, for example, Prompt API for Gemini Nano, go to Chrome flags, and then enable those in order to explore them. And if you want to create an extension, Chrome extension that uses API, the manifest of the extension have to have the AI permissions. Ready to look at one and a new API? Let's take a look at the language detector in action. So I have here what? Okay, no signal. What's going on? Yeah, technical problems. Offline. We got offline. Just a moment.
It disconnected as soon as you turned off the slides.
Just a moment. Sorry for that. Maybe it's not display settings. Display. What about now? Yeah, okay, so technical issues happening, we're offline. Let's look at the example. So we have a simple form with the text box and a button. I want to use the language detector API. How can I do that? So let's go to the implementation. And first of all, what I'm going to do is use the language detector object that exists inside my browser. And I'm going to create a detector. And I give him the expected input languages. That's it. Now, what I can do with this thing here is like detector.detect the value in the text box. And then I can just output to the text box, to the text whatever I detected. Okay? Let's see it in action. Let's take Italian. Non vedo l'ora di mangiare la pizza. I can't wait to eat pizza if I'm a teenager mutant ninja. So let's take this sentence. Let's refresh it. Let's put it in the text box and let's see. No, didn't. Yeah, that's what I want to do. Let's take the sentence and let's detect it. And what you can see here is 0.99% Italian, which is great. I can do something against this model. So we have Task API that gives us the power to do proofreading, language detection, summarizing of articles, and etc. I don't need any server to do that for me. Great. What else can we do with this knowledge? We can, of course, talk about exploratory API. We can use the power of Gemini Nano, the model, and prompt it. Like we did in the language detector, I can create a new object, a new session, a new conversation with the model using the language model object, and then just say, session, prompt whatever I want. And that's it. Okay? Nothing else than that. Let's see it in action. So right now we have an example that doesn't do anything. We don't see anything currently on screen. But what I'm going to do is I'm going to go to the script here and I'm going to do some stuff. Let's code something. First of all, we're checking whether a language model is available. Okay? If the user didn't download the model, which is going to be out of the box installed with Chrome in the future. Currently, it's not because it's behind feature flag. Then I wouldn't get the opportunity to understand whether the model is available, yes or no. Okay? And you want to check that out. Once you check that out, and the model is available, I can create a language model session and then prompt it, like write me a poem. And let's run this example. And hopefully, in a second, we'll see it writing the entire poem. or failing miserably. Take some time, because it's the first run. See that, yeah. The sun dips low, a fairy kiss upon the hills, a golden bliss. Yeah. Okay, I won't continue with this song, but you want it probably with streaming, no? Because we are regular to streaming with the content that we get from the AI. So why not prompt streaming? Write me an extra long poem and then write it to the output. Let's just do this, because I don't want it to do 2 prompts right now. And let's see if it writes me a poem. Yeah. Great. What else can we do with that? Let's give it the power to move on and write the poem for us. We can define a context. Every time you are working with AI, you need a context. Otherwise, it doesn't know what to do with the things that you ask him for, it from. So, for example, I can use the initial prompts value and then say, if your role system, meaning you are the AI, pretend to be a caterpillar, and then answer me the questions that I'm asking you as a caterpillar. Nice. So let's see it in action with the initial prompts. I will just change this thing here, simple prompt, to the second example. And then let's see it in action. Refresh the page. And what is the answer? Roar, stomp foot, shaking the ground. Favorite food? Big question. But what is the context here? Somebody want to suggest something? No, you are after. Yeah, yeah. So I said to the model, pretty model, pretend to be a T-Rex. Okay, and this is why we got this description. And then I just prompted, what is your favorite food? Triceratops or whatever, or I don't know what he wrote. So with that, we can give the AI context. What else can we do with the model in the browser? So if you're working with AI, you are always talking about tools. I can enrich the AI model with the different tools. Can you do that with the model in the browser? So the answer is currently half yes. Okay, half yes, because you can define tools, but you currently need to run those tools. So the AI model will answer, you need to run the tool, and you will need to parse it and run the tool by yourself. This is something that is being worked upon and later on will be standardized, and you will be able to do that. So how can you define the tool? First of all, you just add tools array in the create function for the language model, and then you will have to have a function called execute. That function is what the tool is going to do. You give the tool a name, and that's it. And then you are going to prompt the AI model and ask it to use the tool in some sort of specific occasions. So let's see it in action. Just change this. I'm going to change it to the last demo here. Let's refresh it, and let's hope that we have internet connection and that the service that I'm going to ping is working at the moment, because yesterday it didn't work. So let's pray for the God of demos, and voila. I used some location service, and I asked it to give me the the details about London right now, light, drizzle, and rain. Okay, and I got a JSON response. This is what I was expecting to get. Let's see the code that gave us this example. So here is the tool. The tool has a name, get weather by location. I give it an input schema. You can give input schema and define how the schema of all the input that you're giving the tool works. And I'm going to run later on the execute function. The execute function is going to do whatever I want in the tool. Here it's just going to do fetch the weather of the provided location. That's it. Okay, and then I'm just stringifying the answer to the text, to the div that exists there. Now, how do I use that? Language model.create, put the tool in the tools array, and then you need to define how, when, and when the tool is going to run. So in the context here of the system, I said, you are a helpful weather reporter. If the user asks about weather in specific location, always use get weather by location tool with the location parameter. Okay? I'm saying how to use it. And then when I prompt what is the weather in London, I will have to run the tool, of course, and this is the answer that I will get is get weather by location with some location. It is formatted by the AI in the response, and I will have to parse it. Here I'm using a regular expression. Don't worry, that's not what you are going to do later on. We'll see how to get the better results, okay? And I'm parsing it, and then I run the tool according to the function name that I got from the AI, okay? So your responsibility at the moment to run the tools. In the future, hopefully, it's the responsibility of the local model. Let's continue. And as I said, I did the parsing by myself with regular expression, but you can say to the AI, I need or I want a structured model output using either JSON schema or a regular expression. How do you do that? You create a schema. For example, this is the schema for rating. And once you have the schema, when you create the context, you can say that I want that it will use the response constraint schema that I provided in the previous slide, okay? And that's it. And then the AI model will respond with the schema that I provided, which is great. I don't need to parse everything by myself. Now, let's take all this knowledge and let's work with an application. Okay, for this talk, I created a demo. I really like anima, and in the last year, the main anima that everybody are talking about is solo leveling. So why not creating a family quest task application in the mind of solo leveling? Okay, if you're not familiar with this anima, I'm sorry, but if you're familiar, you will see it in action. So what is this application? This application gives the parents the ability to create mandatory quests to the kids at home, and it leverages the AI model in the cloud, in the local browser. So, for example, if I want that kids need to clean dishes tomorrow, and then I will press the parse button, I'm expecting that the AI will answer with a new quest, clean dishes tomorrow. Let's hope it will work. Okay, system has parsed the following quest. Clean dishes tomorrow, 5th of December, mandatory, yes. If it's assigned to all the kids, and they will get 25 XP if they are going to do that. Now, we have another view here for the kids log. And you can see that the kids quest log is already has 140 experience points because they did some some tasks that their parents asked them for. So for example, if I'm going to complete the task of clean room, okay, we get a system message, quest completed, clean rooms, and in the behavior of solo leveling system, we get a nice response to our kids. And of course, we can look at the calendar view here and see all the quests that our kids are supposed to do. How did I do that? So again, I'm using the AI model in the browser. I created a system prompt. You are the system from solo leveling, and AI designed to manage family tasks. And I literally said to the context whatever I want. For example, when asked to parse a scheduling request for parents, you must output a JSON array of tasks. Great. Now, then I'm using this system prompt here, okay, with the language create function. And then, for example, if I want that the family quest will be created, then I'm just prompting this session again. Generate a short, epic, dungeon clear report or mission accomplished message in the style of solo leveling system for complete. You get the point, okay? I can do whatever I'm doing right now with the cloud AI, with the cloud provider, but locally in my machine. I don't need to go there, spend those 20 milliseconds latency of the web or more than that, and I'm getting the same or close to the same responses. Great. Now, every time you are creating conversation with the AI, if you want those conversations to be saved, session management, you can do it. Currently, this is not part of what the model is doing in your local machine, but you can definitely create storages of all the conversation that you have with the AI using local storage or IndexedDB. And then, whenever the user comes back to your application, you can load all the conversation and continue from the place that the user left the application, which is something that we expect out of our models in the future. We need the context in order to give our users the best experience in our applications. Now, where this thing is leading us is what I think applications will look like in the future, when these local models will be available to us widely and installed with any of the browsers. Right now, it's Gemini Nano. I'm expecting Atlas, the new OpenAI browser, to also incorporate ChatGPT inside their browser, and et cetera, et cetera. So what we are going to do in the future, my guess, is build hybrid applications. Hybrid I mean intelligent UX, local first, you are going to query or prompt the local model, and you will have a cloud backup, okay? So what are the scenarios that I think will be within these hybrid applications? So if you're expecting model capability, if you need simple contextual tasks, stay local. If you need complex tasks, go to the remote cloud. If we are talking about device capabilities, our device is like a mobile phone, less GPU, less CPU. Then client-side model when the user is offline or when you have a cached model. Otherwise, go with heavily computation to the server. Okay? These kind of applications are, in my opinion, the future of how we will create web applications to enable or use AI. So, with that, enrich your application with a local model, with local AI. And I hope you enjoyed this talk. Thank you.